One day, this could well be the scene in Nice. The capital of the French Riviera could be devastated by an unprecedented disaster. Scientists are categorical that sooner or later, the French Riviera will be struck by an earthquake followed by a tsunami.
Yes, there will be an earthquake in the future, but I can't tell you if this will be during my children's life or my grandchildren's life.
The French Riviera is a beautiful place, but there will always be a risk of earthquakes.
We tend to think that earthquakes only happen in Japan, Chile, or the Pacific. We forget that they can also happen in Europe, and in particular in France.
The weather is beautiful, it's calm, it's a beautiful summer day, and suddenly a wave is coming out of nowhere, and it's a tsunami.
It's hard to imagine because it would be pretty apocalyptic.
The region is under a lot of pressure. We have several fault lines, and there's a lot of pressure building up.
Here, for example, you can see that we've had 4 earthquakes since this morning.
Tsunami alert. Evacuate the seaside immediately.
People don't realize that the risk is there, so we need to raise awareness.
The first thing to do is slip under a table and hold on.
The signage that we've put in place to deal with tsunami risk can really save lives.
Most people don't know about the Ligurian Fault, even though it triggered a major earthquake in 1887.
The earthquake in 1887 killed 600 people, but that was in the Nice and the Italian Riviera of the time. The population has since tripled.
Wherever there's been quakes before, we know there will be more.
The more time goes by, the higher the risk of a major earthquake.
The challenge is that scientists cannot predict whether it will be tomorrow or in 10 or even 50 years.
I'm sorry to say we won't have much warning.
An earthquake which would be of magnitude approaching 6.8, 6.9 would be somewhere on the order of 6 to 7 times the Hiroshima atomic bomb.
People think tsunamis look like what they've seen in Hollywood movies, but that's not really it.
It's a mixture of water and mud and trees and cars, and that becomes a big blender.
It's very impressive because the sea fully invades the land.
It would bring the whole economy to its knees.
An earthquake and tsunami in Liguria would be possibly the greatest natural disaster in France.
Stéphane has enjoyed this idyllic setting in Nice for more than 20 years. He runs a restaurant on the Promenade des Anglais, feet away from the water.
The sea is as calm as a lake today. It makes me want to go for a swim. Working on the beach is great. I can't imagine being cooped up in an office all day. That's not for me.
The environment may be exceptional, but it can also be destructive.
In 2010, the sea came up onto the land. It devastated everything. All the beaches were destroyed. We had to close for a month to rebuild everything. It was terrible.
That day, one of the restaurant's cooks was trapped by the raging sea. He only survived thanks to a trapdoor in the ceiling of the stockroom.
There was so much sand. It was up to here.
He escaped onto the Promenade des Anglais at the last moment.
You can't trust the Mediterranean. Everyone thinks it's calm, but it's not at all. When it rages, it's...
The French Riviera isn't safe from the whims of nature. On the contrary, it's dangerously exposed to them. The biggest threat comes not from the sky, but from beneath the Earth's surface. And it could cause the biggest disaster mainland France has ever seen. With 300 sunny days per year, the French Riviera is one of the most popular regions in the world.
Most people who know about France, they of course start with Paris, but then they talk about la Côte d'Azur.
When you say that you live on the French Riviera, people immediately think of Monaco or Saint-Tropez. It's a beautiful region. It's a bit cliché, but it's all about the pleasant lifestyle.
Located in southeastern France, this region features 350 kilometers of coastline where most of its 5 million inhabitants live. The French Riviera is popular for having the sea on one side and mountains on the other. It would be a picture-perfect image if it weren't the product of chaotic natural forces still at work today.
This is a fairly tortured region. Its creation was a painful process.
It has more seismic activity than any other part of mainland France.
Unbeknownst to the locals, a war of the titans is constantly underway beneath their feet. The cause is something called plate tectonics. The Earth's crust is formed of 12 different pieces, which fit together like a puzzle.
It's hard to imagine the dimensions of the Earth's crust. We talk about pieces that are thousands of kilometers thick in some areas.
These 12 plates float on top of the Earth's molten core, moving closer together or farther apart and sliding against one another. Just a few hundred kilometers from the French Riviera, two of these plates meet. The convergence is located north of the African continent, where the Eurasian and African plates are moving closer together at a rate of 2.15 centimeters per year.
This results in a clash between two major plates.
This is what we call a convergence zone. In a few million years, the Mediterranean will be gone.
In southeastern France, this phenomenon created the Alps, the highest point of which is 4,808 meters. It also resulted in the creation of underwater trenches more than 2,000 meters deep.
The most visible effect is mountains, but we have the same thing below the water.
Because of the movement of plate tectonics, the Earth's crust is torn apart, creating faults. Colossal forces build up along these fault lines, generating earthquakes. There are three faults on the French Riviera: Saint-Sauveur-d'Honoré, Blozasque, and Saorge-Tadja. They're under constant surveillance by the GéoAzur lab, which is overseen by the CNRS. Françoise Courbelex is a seismologist and research director there.
It's quite simple. Fault lines are cracks in the Earth's crust. And it's along those cracks that earthquakes take place, when the two sides rub together.
Pressure builds up along the fault lines. When there's too much of it, it's suddenly released. The energy is propagated in the form of waves that make the Earth shake.
Here we have a map that shows our seismological stations in southeastern France. We have 40-some stations that monitor ground vibration at all times. Here, for example, you can see that we've had 4 earthquakes since this morning. The last one happened around an hour ago. It was on the Italian border, and it had a magnitude of 0.8, which is very small. These small quakes show that the area is active.
La région est sous pression.
The region is under a lot of pressure.
Des forces qui s'accumulent.
These forces are really building up.
On a de nombreuses
We have
failles
several faults that were formed when the Alps came into existence 50 million years ago,
il y a 50 millions d'années, donc
which are weak points in the Earth's crust,
dans la croûte terrestre,
and will be the first to break because of the pressure buildup.
cassées du fait de l'accumulation de ces forces.
Compared to larger faults such as the San Andreas Fault on the west coast of the United States, the Mediterranean faults may seem small, but that doesn't make them any less dangerous. One of them deserves particular attention. A fourth fault, located not on land, but below the sea. It's called the Ligurian Fault. It's just 20 kilometers off the coast, over 2,000 meters deep, and nearly 80 kilometers long.
The Ligurian Fault is below the French Riviera.
We know it's dangerous. We don't see much seismic activity there right now, which isn't necessarily reassuring because it means that it's stuck. The pressure's building up, and one day it will break.
The less we hear about the Ligurian Fault, the more cause we have for concern. Scientists are worried about the possibility of a large earthquake. If the Ligurian Fault were to wake up, the consequences would be catastrophic for the cities of the French Riviera.
The earthquake phenomenon by itself is not lethal, as opposed to other kinds of disasters, of natural disasters, such as, for example, volcanic eruptions.
If you have a big earthquake in a desert, there's no risk, because there's nothing to break. If we were to have a big earthquake underneath, not a massive one, but just a decent-sized one, there would be a huge amount of risk because of the infrastructure and the people living there.
The roof will fall on you and you will die, not because of the earthquake itself, but because the structure in which you had the misfortune of finding yourself has collapsed on you.
These images of Japan, Turkey, and Indonesia seem unimaginable in France. Yet, there's a good chance the French Riviera may one day see the same kind of damage. We just don't know when.
The challenge is that scientists cannot predict whether it will be tomorrow or in 10 or even 50 years.
Dans 10 ans, dans 50 ans.
For now, no one can predict earthquakes, neither in France, nor in Japan or California. We have a lot of data. We have scientists around the world working hard and sharing their data with one another, but we're still unable to predict earthquakes.
We don't know how to predict them. Why? Because we still don't fully understand the physics of earthquakes. We still have a lot of work to do in that respect. It's also because we haven't figured out the physics of the process. We don't know which measurements to take, so we can't design the right tools to take those measurements.
Sometimes we have small tremors before a bigger one, but sometimes those small tremors are not followed by a larger earthquake. So it's very complicated. And for now, we're still at a bit of a loss. Seismology is still a very new science.
While predicting earthquakes may be impossible, scientists do model different scenarios to prepare for future potential disasters.
The more time passes, the more likely it is that a big earthquake will occur.
Sooner or later, the Ligurian Fault off the coast of Nice will wake up. And this is what could happen. Today is a day like any other on the French Riviera. A sunny day where thousands of tourists have flocked to the beaches.
The weather is beautiful, it's calm, there is no wind, it's a beautiful summer day.
No one knows it yet, but off the coast, an underwater monster is about to awaken from a very long slumber. Around 4 p.m., the Earth suddenly starts to vibrate.
Everything starts to shake, and it takes a few seconds for people to realize that there's an earthquake going on.
The Ligurian Fault has woken up. Just 20 kilometers from Nice, a 35-kilometer crack forms. In a fraction of a second, the French Riviera is shaken by a 6.9 magnitude earthquake.
An earthquake which would be of magnitude approaching 7, let's say 6.8, 6.9, would be somewhere on the order of 120 kT. We are talking something on the order of 6 to 7 times the Hiroshima atomic bomb.
Scientists believe the ground could shake for up to 12 seconds.
You feel a very powerful vibration, strong enough to make me fall off my chair, for example.
Things around you would start to move. That feeling of movement and instability of the ground would continue to increase until it reaches a climax.
It's hard to imagine because it would be pretty apocalyptic.
From Saint-Tropez to Menton by way of Nice, there would be severe damage everywhere within 50 kilometers of the epicenter of the earthquake. Buildings would struggle to stay standing, and people would be trapped inside.
If you're in a house, you'll hear the dishes moving in the cupboards, see lamps swinging from the ceiling, and have furniture detaching from the walls. That's one of the biggest risks, actually, furniture falling over. Unfortunately, a lot of people are seriously injured or even killed by bricks, cinder blocks, or drop ceilings falling on their heads and such, resulting in a lot of victims.
And during the earthquake, the chimney will fall, and the poor guy who's walking on the street there may be hit by a chimney falling from a height of a few meters, and that's it.
In Nice, the old town is at especially high risk. These buildings date back to the 19th century.
The most vulnerable part of Nice is in the Old Town. There are around 500 buildings there. They're old constructions made of masonry, which is to say, stones with lime mortar.
People used to build, buildings with several stories by just laying bricks on top of each other without a very strong reinforcement. And these are very dangerous buildings.
With just 1% of buildings being renovated per year, it will be 100 years before all of the old town's buildings are up to standard. There's no guarantee the Ligurian Fault will wait.
If one building collapses, it could cause other buildings to collapse in turn. That's one of the risks, the domino effect.
The tremors here are especially strong because the city is at risk of an exacerbating factor, wave amplification.
As the seismic waves make their way to the surface, they can be amplified by the last 10, 20, 30, or 100 meters of soil. If you have very soft soil, like you have around rivers, for example, it will magnify those waves.
When they penetrate the fragmented rock beneath Nice, these seismic waves find themselves trapped. As they search for an exit, they bounce off the walls, which are made of harder rock. This game of ping pong increases the amplitude and the duration of the tremors shaking the surface.
Seismic tremors can be multiplied by 10 or even 20 in some cases, but even a factor of 2 or 3 is already huge.
Nice could meet the same fate as Mexico did in 1985. That year, the amplified waves destroyed the Mexican capital and caused more than 10,000 deaths. Yet the epicenter of the earthquake was 400 kilometers away.
They built a city on a former lake that had dried up, which meant they were building on very soft, loose soil. The seismic waves got trapped in that basin. The 1985 earthquake taught seismologists all around the world that, depending on the location, there could be major seismic side effects and a lot of amplification.
In urban settings, whether it be Mexico or Nice, danger is everywhere. Certain types of vital infrastructure for the region were not designed to withstand such a shock. Roads, bridges, and tunnels. The entire city would be full of hazards.
We have pipes carrying gas through the middle of the city. If those pipes were to break during the quake, there would be gas leaks and fires.
That is a major problem, gas lines, because if you have gas leaks and at the same time you break power lines, the spark will ignite fires. If a storm is capable of shutting down electricity in a community, think of what an earthquake can do.
"12 seconds after the earthquake began, the ground finally stopped shaking. The electrical grid and communication networks are down. Any that are still working will be immediately overloaded.
If you are in a big earthquake, don't count on your cell phone to do anything. For the simple reason that everybody is going to do that at the same time.
People's first reflex is usually to call their family and loved ones to see if they're okay. You shouldn't do that, because it floods the networks. These are needed for crisis management purposes.
A cellular system is not designed to be used by every subscriber at the same time.
Just a few minutes after the earthquake, the first emergency response vehicles hit the road, but their progress is considerably slowed. Nice is cut off from the rest of the world. To the west of the city is the Var River, which forms a deep ravine. The city is bordered by mountains on all other sides.
One really important factor is the Var River. There are several bridges, which are absolutely essential to get into the city.
The roads to the west and east would be cut off in the event of a major earthquake, and Nice would become a peninsula. The only way to reach it would be via the challenging mountain roads.
The roads are already crowded on a normal day. In case of an earthquake, it would be complete chaos.
Unfortunately, the earthquake along the Ligurian Fault was only the first part of this disaster scenario. An even more worrisome threat still looms above the fifth most populous city in France. As Nice is plunged into chaos, the threat approaches.
If you feel the shaking and you are close to the water, just run away. Run away in the opposite direction, away from harm's way.
The waves are so fast, they'll sweep up anything in their path.
Even the best swimmers can't fight a current that reaches 1 or 2 meters per second. You're just going to be as good as a debris.
After the earthquake comes the tsunami.
We tend to think that earthquakes and tsunamis only happen in Japan, Chile, or the Pacific. We forget that they can also happen in Europe and in particular in France. France has forgotten about that.
People think tsunamis look like what they've seen in Hollywood movies, an enormous wave. But that's not really it.
They feed many a fantasy, but tsunamis are actually the result of a simple phenomenon. When an earthquake occurs, the fault lifts several meters up a slab of rock that's multiple kilometers across.
What's so impressive about the energy that's produced is that the rock may be lifted just 1, 5, or 10 meters at most, but across an area spanning many square kilometers. That gives you an idea of the volume. If we look at the earthquake and the tsunami in Sumatra, the fault was moved along a length of 1,000 kilometers, a width of 200 kilometers, and 5 to 10 meters high.
This brutal deformation of the seabed causes the movement of a phenomenal amount of water.
So any movement on the bottom will translate into a movement on the surface. If the seafloor moves up, then the water moves up. And now you have a hump of water on the ocean surface.
A wave is formed, which is barely visible. The volume of water that's displaced, however, is massive.
It's nothing like a surfing wave. The whole sea level rises up because the wave is so large.
The wave begins its unbridled race towards the coast at the speed of a commercial airliner, between 500 and 800 kilometers an hour. As it gets closer to the coast and the ocean floor rises, the wave loses much of its speed. But it gets dangerously higher.
The waves come in very fast, then they start to slow down, like in a traffic jam, and become concentrated at the coast. When they're concentrated, the water level rises.
The tsunami that could have been 0.5 meter to 1 meter in deep water may suddenly become a wall of water of 10 or 15 meters arriving on the shore.
If we look at what happened in Indonesia in 2004, when the wave was out at sea, it was measured using satellite altimetry as having an amplitude of around 1 meter. But at the coastline, the measurements taken from land show us that the wave reached heights of 20 to 30 meters.
You have to imagine this wall of water. Then behind that wall, you have an enormous length of water, kilometers of water behind. So unlike a swell, which maybe breaks and then retreats within a few seconds, the tsunami is going to keep coming at you for minutes at a time.
It's very impressive because the sea really comes up onto land and it moves at very high speeds. It causes much more damage than any normal storm.
It forms a front that advances like a bulldozer and destroys everything in its path.
There's nothing hypothetical about the scenario of a tsunami hitting the French Riviera. Scientists take it very seriously, especially because it has already happened in the past. We've all but forgotten it today. It happened in 1887.
Disasters tend to be forgotten within 10 years or so. Those who remember are people who lived through them or lost loved ones to them. But in terms of collective memory, we don't remember. So something that happened in 1887.
On February 23rd of that year, off the coast of Imperia, Italy, the Ligurian Fault awoke. France and Italy were struck by a 6.8 magnitude earthquake, followed by a tsunami. The disaster left 646 people dead, 776 injured, and 20,000 without a home. Then, an East correspondent for the Gil Blas periodical, author Guy de Maupassant, wrote,
I was sound asleep when I was suddenly awoken by a terrible trembling. During the first dreadful seconds, my initial reaction was to think the house was falling down. But as my bed jumped around more and more, the walls began to crack, and pieces of furniture crashed into one another with a terrible racket. I realized we were experiencing an earthquake. The refuge of any person who is suffering or under threat is their roof and their bed. But during an earthquake, nothing is more dangerous than your bed or your roof.
Today, no one remembers the words of de Maupassant. The residents of the French Riviera have forgotten the danger lying in wait beneath their feet.
Wherever there have been quakes before, we know there'll be more.
Maybe half of it failed during that 1887 earthquake. So the other part has not failed yet.
If one part breaks, the part next to it will also break in turn. If one part of the fault had a buildup of pressure and then released that pressure in the form of an earthquake, there's no reason the section next to it shouldn't do the same thing.
I can say with certainty that it is impossible to predict exactly when a tsunami or an earthquake will occur. However, what I can also say with certainty is that they will occur in the future. It's a question of when. It's not a question of if.
To try to answer this question, scientists have only one solution for now: establishing the seismic cycle of the fault, or the frequency with which it produces earthquakes and causes tsunamis. To that end, they must trace the history of the fault.
When an earthquake takes place somewhere, we'd like to be able to know if another earthquake is likely to take place soon, or if we can safely assume it will be 200, 300, 1,000, or even 10,000 years before the next. To answer that question, we have to study the object that generated the earthquake, which is to say, the fault itself.
What is the seismic cycle of the Ligurian Fault? When will the next tsunami occur? In 2018, a team attempted to approach the fault using underwater robots. Frédéric Leclerc took part in the operation as an expert in underwater fault observation. 2,000 meters below the surface, the robots hunted for signs of the 1887 quake.
We were looking for something that looked like staircase steps, but we didn't find anything. The seabed was flat, so maybe the deformations caused by the 1887 quake have been covered by recent sediment.
In the depths of the Mediterranean, the Ligurian Fault is hard to spot. Land faults such as that of Blausask offer scientists better conditions for observation.
In order to comprehend the type of earthquake that is likely to occur, we need to understand its past. We can look, for example, at these striations here along the fault line. They're an indication of a particular kind of movement, which means that based on the position and direction of these striations, we can reconstruct the relative movement of the rock on either side of the fault line. That's obviously very useful, because we can take samples of the rock along the fault, look at how they've been deformed, and try to decrypt what happened in the past in order to try to understand what might happen in the future. When we attempt to investigate fault lines at sea, it's obviously much harder because taking samples is a lot more difficult.
The scientists may not have been able to observe the Ligurian Fault, but they nevertheless gathered some important information during their underwater expedition by taking sediment core samples. Their analysis transported them back in time enabling the scientists to prove it was the Ligurian fault that caused the 1887 earthquake. Sébastien Mijon is a geologist at the GéoAzur lab.
What we have here is around 150 to 200 years of history. In these sediment core samples, we have successive layers of sediment that have been deposited over time. And as you can see, the appearance of these sedimentary strata is completely different. Here it's more clay. And then we have a layer of sand in between the layers of clay. That's the part we're most interested in, because these sandy deposits reflect an event that was caused by the 1887 earthquake.
Other sediment samples revealed that another earthquake had taken place in 1644 and another 80 years earlier in 1564. But that's not enough to establish the seismic cycle. The Ligurian fault likes to keep its secrets.
It's very difficult to establish the seismic cycles of slow faults like this one. It's hard enough in Mexico or California, where the faults are much more active. But with faults that only move every 200, 400, or 1,000 years, it's very hard to figure out what the cycle is.
When it wakes up, the Ligurian fault could catch people off guard. That day, when the earthquake stops, everyone will think the worst is over. Yet, 20 kilometers away, the tsunami will have already begun rushing towards the coast.
I'm sorry to say we won't have much warning.
Once the earthquake has taken place, you basically have 4 or 5 minutes to react, which isn't very much.
The worst-case scenario would be a tsunami arriving at the peak of the summer. And the summer period is long on the French Riviera. It's pretty much from May to October or November. So during that period, the beaches are covered with people. And so should a tsunami, even a moderate tsunami, occur during that period, then the potential for loss of life and destruction of properties would be large.
With the Ligurian fault breaking along an area 35 kilometers long and 15 kilometers wide, it has displaced more than 500 square kilometers of rock.
A large part of the region would be lifted up.
And caused the displacement of a gigantic volume of water.
All the coastal cities are under the threat of a tidal wave. Not a single city would be spared.
The tsunami continues towards the coast.
The first thing you have to do is escape as fast as you can when you see something approaching the shore.
The thousands of people on the beaches would have just seconds to react. But the layout of some coastal areas makes evacuation difficult, if not impossible. Like here on Fontaine Beach in Antibes, where the railroad line along the beach acts as a barrier. Or on the shores of Nice, which have limited escape points.
There are high walls that cannot be climbed. That means you'd have to move lengthwise along the beach to reach a staircase. You'd lose precious minutes that could make all the difference.
The stairs have to be both wide enough to let many people go up at the same time, and numerous enough to allow thousands of people, which is what we see on our beaches in summer. So several thousand people to evacuate the beach in a matter of minutes. I don't think that's the case today. I doubt the beaches could be evacuated quickly.
it's already too late. A tidal wave reaching heights of 4 meters and speeds of 40 kilometers per hour has struck the French Riviera.
It might not sound that high because you're picturing a wave, but that's not what it is. It's a wall of water that sweeps up everything in its path.
Just 50 centimeters of water moving at a few kilometers per hour is enough to sweep people off their feet.
Jesus Christ, look at that.
Footage from Thailand during the 2004 tsunami illustrates the power of this phenomenon.
You would be swept up and carried along with the water. You'd have no chance of resisting the water pressure, so you'd be dragged along with it wherever it goes.
Even the best swimmers can't fight a current that reaches 1 or 2 meters per second. So above that, you're just going to be as good as a debris. You just moved around without any possibility for resisting the current. It's almost similar to being dropped in a river that has rapids. You're going to lose quickly your sense of direction because you will have lots of eddies and vortices.
You would be literally ground up by the massive water and energy that would hit you.
In Nice, the wave would be stopped by the high wall bordering the Promenade des Anglais.
The actual center of Nice is approximately 3 to 4 meters above sea level. That definitely gives it some protection.
But not all cities on the French Riviera are so lucky. And after swallowing up the beaches, the tsunami would continue on its way.
If we look at other cities like Cannes or Fréjus, for example, there are many buildings that are at sea level, which means that even if the wave were just 2 or 3 meters high, it would penetrate into the town itself.
The waves are so fast, they'll sweep up anything in their path.
They whisk off everything along the way. Cars, boats, bicycles, garbage cans, anything. That means that the water grows denser as it goes because it's full of all sorts of solid objects. So when it reaches the walls of a house, for example, it tears them off.
It's a mixture of water and mud and trees and cars and pieces of about everything you can imagine. And that becomes a big blender.
In the city of Nice alone, the consequences of such a disaster would be devastating. According to estimates from the BRGM, the French Bureau of Geological Survey, it could cause more than 200 deaths and 3,700 injuries. 64,000 people would be left without a home. There would be property damage valued at up to 29 billion euros. These estimates could get much worse a few seconds later when an underwater avalanche is triggered. After the earthquake and the tsunami, the French Riviera is threatened by yet another natural disaster. On the slopes of the seabed off the coast, a thick layer of sediment is released.
Just like how a buildup of snow on a mountain can cause an avalanche, on underwater slopes, you can have an accumulation of sediment that will eventually destabilize and result in an underwater avalanche. Compared to snow avalanches, underwater avalanches are much larger. They can be hundreds of meters thick, several kilometers or even tens of kilometers wide, and move at speeds of several kilometers per hour.
At the surface, the underwater avalanche has tragic consequences. A second tsunami occurs, aggravating the situation even more. Stephen Greeley is a professor of ocean engineering. In his lab at the University of Rhode Island in the United States, he studies the formation of these destructive waves.
This is representing a landslide tsunami starting on the land, and an earthquake occurs and shakes the sediment, then it falls into the ocean, and it creates a wave. The waves propagate, they go up the slope, and then they impact the beach.
Tsunamis caused by landslides move just as quickly as those caused by earthquakes. But since they're generated closer to the coast, you have less time to understand what's happening and see it coming.
We could have one disaster after another, resulting in several destructive events in a matter of minutes.
That's what happened on September 28, 2018 in the city of Palu in Indonesia. That day, an earthquake triggered a series of 7 underwater avalanches, causing a tsunami 12 meters high. An earthquake, a tsunami, and an underwater avalanche. The French Riviera could fall victim to a disastrous series of events. With no way of fighting these natural phenomena, prevention is the only possible solution.
Don't take elevators. If you're at work, take the stairs, never the elevator. If you're outside, same thing. Stay away from electrical poles and trees. Anything that could fall on you.
The fastest thing to do is cover your neck, slip under a table or anything close by, and hold on.
If you feel the shaking and you are close to the water, just run away. Do not go to the beach to see what's happening. Run away in the opposite direction, away from harm's way.
On the French Riviera, the city of Cannes is leading the way. Over the past few months, local authorities have been working to install a tsunami alert system on their coastline. Yannick Ferrand, the risk management director, ensures they're working as they should.
Yannick for Laurent, you can initiate the test. Thank you.
This is only a drill. This is only a drill. This is only a drill. Tsunami alert. Evacuate the seaside immediately. Exercise.
They have identified a number of safe points all over the city.
Yeah, that's good, because people will come from here.
These areas, located more than 5 meters above sea level,
Can you move it to the side a bit?
or more than 200 meters from the shoreline, offer protection to the population.
We're more than 5 meters above sea level here, so we're safe. People can come to this slope for safety.
Signs have been placed all along the shoreline to lead people to these safe points.
Let's start here. Start here. The sign shows the name of the safe point, Suquet, the direction, and the distance from the seaside to the safe point. The signage we've put in place to deal with the risk of tsunami and direct people to safe areas, all the stickers and pavement markers, yes, they can really save lives.
Please follow the signs to a tsunami safe point.
But in order to protect people, anti-seismic standards must also be met. In France, they are in effect in all regions at risk of earthquakes and have been since 1955.
The purpose of earthquake-proof construction isn't to prevent damage to buildings, but to keep them from collapsing.
The French Riviera is under the shadow of a growing threat. Will it be ready the day the Ligurian fault awakes?
An earthquake and tsunami in Liguria would be possibly the greatest natural disaster in France.
I think human beings feel how small and vulnerable we are in the face of the forces of nature. We like to think that the environment we know is going to be the same forever, but